Hello everyone. Today we will going to study about the topic redox reactions in detail. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. So this is our index slides and these are the major topics which we're going to study, which we're going to cover today. It consists of these topics like electronic concepts of oxidation and reduction, some important oxidants, some important reductants, oxidation number, redox reactions, balancing of redox reactions, and lastly, we will conclude by the summary. Okay, so let's start with our first topic, that is electronic concepts of oxidation and reduction. So, loss of electron by an atom is called oxidation and de-electronation, while gain of electron by an atom is called reduction or electronation. So basically, oxidation and reduction, they're opposite of each other. So where the loss of electrons is happening, that means oxidation is happening. Where the gaining of electron is happening, that means reduction is happening, right? And oxidants or what are oxidants and oxidizing agents? So these are the substances which oxidize others and itself get reduced by gaining electrons. Okay, so oxidation and reduction is a process, right? Oxidation is a process, reduction is a process, but through which this process is occurring, they are known as oxidants, oxidizing agents, or reductants or reducing agents. So from this category, oxidants are particularly those substances which oxidized others and itself get reduced by gaining the electron, right? That is their oxidation number decreases during a reaction because they are gaining the electrons, so oxidation number will decrease for the oxidants. Similarly, for the reductants, uh, they are the substances which reduce others because as the name says reductant, so they reduce others but itself get oxidized, losing electrons. Okay, and as they are losing electrons, so their oxidation number increases during a reaction. Okay, let's further studies about some important oxidants. So some important oxidants used in oxidation are given below. So we used oxidants in oxidation process and reductants in reduction process. Okay, so let's see some important oxidants. So molecules of most electronegative elements such as and halogen are oxidants, which is used in the oxidation process. Similarly, oxides of metals and non-metal such as magnesium oxide, calcium oxide, chromium oxide, uh, water, CO2, carbon dioxide. These are the oxides of metal and non-metals which act as which used as a oxidants in an oxidation reaction. The compounds having either of an element in their highest oxidation state, such as K2Cr2O7, KMnO4, HClO4, H2SO4, HNO3, FeCl3, HgCl2, or KClO3, etc. These are the compounds in which either of an element of a compound is having highest oxidation state. So they are also act as an oxidant. Permanganate ion act as strong oxidizing agent, and in acidic medium it always produces 5 electrons per formula unit irrespective of the reducing agent. So this is also important point that permanganate ion act as a strong oxidizing agent and it produce 5 electrons in the acidic medium per formula unit irrespective whatever the reducing agent is present in the reaction. Okay, so now some important reductants used in the reduction. So in the reduction process we use reductants. Okay, So for all metals such as sodium, aluminium, zinc, etc., and some known metals like carbon, sulfur, phosphorus, hydrogen molecule, etc. So they are used as a reductants in the reduction process, in the reduction reaction. Metallic hydrides such as sodium hydride, lithium hydride, potassium hydride, calcium hydride, and halogen acids such as HCl, HBr, or HI. So these are the metallic hydrides and halogen acids. They also used as a reductants in the reduction process. The compounds having either of an element in their lowest oxidation state, such as H2C2O4, FeSO4, Hg2Cl2, Cu2O, SnCl2, right? So these are the compounds in which either of their element are present in their lowest oxidation state, and thus they act as a reductant in the reduction process. Okay? So equivalent weight of oxidizing agent or reducing agent. So how can we find out the equivalent weight of oxidizing agent represented by O in the formula, and reducing agent or reducing agent represented by R in the formula? So let's write the equivalent weight for the oxidizing agent or reducing agent, which is equals to molar mass of that oxidizing agent slash reducing agent divided by the number of electrons lost or gained per formula unit of reducing agent or oxidizing. Okay, so whether the number of electrons will be lost or gained, it will depend on the compound, whether it is a reducing agent or a oxidizing agent. And this is the final formula we have for the equivalent weights of any oxidizing agent or reducing. H2O2, there is a exception. There is a compound named H2O2 is both oxidizing and reducing. So it acts as both. It is used as both like oxidizing and reducing agent, but its equivalent weight as either oxidizing or reducing agents are same. Okay, so H2O2 is a compound. It can be used as both like oxidizing or reducing agent. But if we want to find out the equivalent weight, if we find out the equivalent weight for H2O2, it will be same for both oxidizing and reducing agent, that is 17. Okay, this is the point to remember. And now let's see the definition of oxidation number. So what is oxidation number? The real or imaginary charge. The real or imaginary charge which an atom appears to have in its combined state is called oxidation number of that atom. So if we want to find out the oxidation number of any atom, so oxidation number is basically uh, in a compound, in a combined state compound, a real or imaginary charge which an atom appears to have, right, is called oxidation number of that compound or an atom. So rules for assigning the oxidation number. So if we want to assign the oxidation number to a particular atom, how can we do that? There are some rules for it. First one, the oxidation number of an element in its elementary state and a compound is 0. For example, hydrogen in H2 molecule oxidation number is 0. Sulfur in S8 oxidation number is 0. So basically molecule should or compound should also have same element, same atoms. Same atoms, when same atoms combines, they form a particular molecule. So if we want to if we find out the oxidation number of that particular atom, it will be 0, whether it is in its elementary state or in a compound. Second rule, the oxidation number of an ion is equal to the electrical charge present on it. If any electrical charge is already present on an ion, that will be its oxidation number. Okay. Third, oxidation number of fluorine is always -1 in all of its compounds. So fluorine, whatever the compound is, whatever the molecule is, fluorine always exhibit the oxidation number is equal to -1 in all of its compounds. Fourth, the oxidation number of alkali metals is always +1. Alkali metal means group 1, oh, group 1 element. And those of alkaline earth metal is plus. Okay, alkaline earth metals is group 2 elements. So the group 1 and group 2 elements or alkali or alkaline earth metals, they exhibit the oxidation number of +1 and +2 respectively always. Okay. And oxidation number of hydrogen is +1 except in ionic hydrides. So if we see the oxidation number of hydrogen, it will be +1 everywhere except in ionic hydrides where it is -1. In ionic hydrides, the oxidation number for hydrogen will be counted as -1. And other than that, everywhere in any compound, the hydrogen oxidation number will always be +1. Next is two oxidation numbers of nitrogen are -3 and +. When it is bonded with less electronegative and more electronegative atoms respectively. So -3 for the nitrogen oxidation number when it is bonded with less electronegative atom, and +3 is the oxidation number for nitrogen atom when it is bonded to more electronegative atom. Okay, next is oxidation number of oxygen is -2 except in OF2 it is +2, in O2F2 it is +1, in peroxides it is -1, and in superoxides it is -1/2. So it is observable that the oxidation number of oxygen is -2 in every compounds except some of the compounds like OF2 in which oxidation number is +2, O2F2 oxidation number of oxygen is +1. In peroxides also the oxidation number of oxygen is -1, and in superoxides the oxidation number of oxygen is -1/2. Other than that, in every molecule the oxidation number of oxygen will be minus. Next is the oxidation number of halogens is always -1 in the metal halides. Halogens means group 17 elements. So the oxidation number of halogens is always negative, always -1 in the metal halides. Next is in interhalogen compounds, the more electronegative element out of the two halogens gets the oxidation number of -1. And this is also important that if we are talking about the interhalogen compounds, a compound in which two halogens are present, so the more electronegative element out of two halogens. So out of two halogens, the one which is having a more electronegativity gets the oxidation number of -1. Okay. Okay. Last is that oxidation number of metals in amalgams and carbonyls, for example, FeC5 is always 0. Okay. So we have studied some rules here about the oxidation number, that how can we assign the oxidation number to a element in a compound. There is a note, valency of an element, valency of an element is always a whole number. It can neither be 0 and nor fractional, while oxidation number may be positive or negative. It can be 0 or fractional. Okay, so valency can only be a whole number, can never be 0, it can never be fractional. But oxidation number on the other hand may be positive, may be negative, it can be 0, it can be fractional. Everything is possible. Okay, now let's see the detail about the redox reaction. As we are studying it, as we are studying the chapter redox reactions. So let's see, after understanding every, common or basic definitions, now let's move to the topic redox reaction, that what is it? So the reaction which involves oxidation and reduction as its two half cells is called, half reactions is called redox reaction. So in the redox reaction, the both oxidation and reduction process is happening simultaneously. A redox change occurs simultaneously. Okay? So basically, oxidation and reduction both happen simultaneously in a redox reaction. That's why they are called as redox. Re for the reduction, Red for reduction, and OX for oxidation. So it is redox reaction. Redox reactions are of the following three types. First one, intermolecular redox reactions. They are the reactions that involve the reaction between two substances. One of them is oxidant and the other is reductant. Intermolecular means two molecules are present. One is act as oxidant, other is act as reductant. Example is given like 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4 will give us 2 MnSO4 plus 5 Fe2SO4 plus K2SO4 plus 8H2. Here, in this reaction, this is a type of intermolecular redox. This is an example of intermolecular redox reaction in which one molecule is acting as a reductant and other molecule is acting as an oxidant. Okay, uh, that is the basic definition of intermolecular redox reaction. Now let's see the another thing that these are further divided into two types. Now, intermolecular reduction reaction will also divide into two types. First is combination, second is displacement. Combination reaction, as the name says, in which two atoms or molecules combine together. Okay, but the two atoms which are combining should be in their zero oxidation state. They are combining together, and the one gets oxidized while the other gets. Okay, so for example, there is a reaction here of carbon plus oxygen give us carbon dioxide. There are atoms having the oxidation state 0. One is reductant, other is oxidant, and they combine to form carbon dioxide, and in which one gets reduced and other gets oxidized. Right? As 0 is going to plus 4, it is oxidized, and 0 is going to minus 2, that is oxygen gets reduced. This is an example of combination reaction. Second type of intermolecular reduction reaction is displacement reaction, in which an atom or ion in a compound is replaced by other atom or ion. As the name says, displacement. In the displacement reaction, an atom or an ion in a compound is replaced by other atom or ion. Displacement reaction are further divided into two types. First one is metal displacement reaction, in which metal with low reactivity displaced by metal with high reactivity. For example, copper sulfate plus zinc, one is reductant, one is oxidant, giving us copper plus zinc sulfate. The metal gets replaced each other. This is the example of metal displacement reaction. And let's see the second type, which is non-metal displacement reaction, in which non-metals is displaced. So this is the reaction like 2 sodium plus 2H2 giving us 2 NaOH plus H. So non-metal is present in the reaction and the non-metal is getting replaced and forming a compound. Okay, but we are studying it under the intermolecular reduction reaction, right? So in the all type of reactions, one reductant molecule and one oxidant molecule is always present in the reaction. Now let's move to the second type, which is intramolecular redox reaction. These are the reactions that involve oxidation of one element of a compound as well as reduction of other element of same compound. As we are saying that intramolecular means in the same molecule. So within a same compound, within a same molecule, one element is involving in oxidation and other element in the same compound is involving in reduction. This is the intramolecular redox. Decomposition reactions are also called intramolecular redox reactions. Okay, but to be a redox reaction, it is essential that one of the products of decomposition must be in the elemental state. For example, NH4 whole twice Cr2O7 on heating, it is giving us N2. In the elemental state, Cr2O3 plus 4H. Okay, this is an example of intramolecular redox reaction. Third type is auto redox or disproportionation reaction. These are the reactions that involves oxidation and reduction of same element. Okay, until now we are talking about the oxidation and reduction or reductant or oxidant of two different compounds and then two different elements of same compound. But now in the auto redox or disproportionation reaction, the reduction or the oxidation is happening of same element in a reaction. Okay, for example, Cl2 plus 2 OH minus giving us ClO minus plus Cl minus and H2. So same element Cl2 is reducing and oxidizing both. Okay, so these type of reactions are auto redox or disproportionation reaction. Now, let's see how to balance the redox reaction. So, why I'm cutting this? Yeah. So let's see how we can balance the redox reaction. So, two methods are there which is used to balance the redox reactions. First, ion electron method. What we will do? This method involves the following steps. First, write the redox reaction in ionic form. Whatever you want to write out the redox reaction of, just write it in the ionic form. Split redox reactions into oxidation half and reduction half cell reaction. Okay. Uh, what we have to do in the redox, as I said, that both the process of oxidation and reduction is happening simultaneously. So what we have to do? We have to split these two. We have to write oxidation half reaction and reduction half reaction. Okay. Balance atoms of each half reactions by using simple multiples. Now, as we have one half reaction of oxidation, half reaction of reduction, what we have to do? We have to balance the atoms in each of the half reactions by using simple multiples. Now, for balancing hydrogen and oxygen, if the reaction is carried out in acidic medium, add H positive ion and H2O to the appropriate site. Similarly, for basic medium, add OH minus and H2O to the appropriate sites. Now, if we have a reduction half cell, we have a reduction half reaction, we have a oxidation half reaction. Now, for balancing hydrogen and oxygen in each of them, if the reaction is carried out in acidic medium, we have to remember, or we have to take care of this also, that if the reaction is carried out in the acidic medium, we have to add H positive and OH and H2O to the appropriate sites wherever it is needed. Similarly, in the basic medium, if the reaction is happening in the basic medium, we have to add OH minus rather H plus, right? Because it is in basic medium. So we have to add OH minus and H2 to the appropriate sites for balancing hydrogen and oxygen atoms. Now, balance the charge on both the sides and multiply one or both half reactions by suitable number to equalize the number of electrons in the both equation. Lastly, after balancing the atoms, we have to see whether our charge is balanced or not at the reactants and the product side or not. So we have to balance the charge on both the sides, okay, reactants and products, and multiply one or both the half reactions by a suitable number to equalize the number of charge or number of electrons in both the equations, in the reduction half equations and the oxidation half reaction. So for balancing charge, what we have to do, we have to multiply by a suitable number to the both sides, and we have to equalize the number of electron in the both oxidation half reaction, reduction half reaction. Lastly, what we have to do, add the two balance half cell reaction. Now we have the two half reactions. Sorry. Now we have to add the two half reactions, oxidation and reduction, which is balanced, and cancel the common term. Okay. This is ion electron method. Second method is oxidation number method. So this method involves the following steps. First, assign oxidation number to the atoms in the equation and write separate equations for atoms undergoing oxidation and reduction. Okay. Now find the change in the oxidation number in each equation and make the change equal in both the equations by multiplying suitable integers. Lastly, after adding both the equations, add the both equation and then complete the balancing by balancing hydrogen and oxygen atom. So in the oxidation number method, we focus on the change of oxidation number. In the ion electron method, we have in the ion electron method, we have to see whether the charge is balanced or not, atoms is balanced or not, and then we have to add. And we have to separate the reaction in the two half reactions also, right? But in the oxidation number method, we just have to see the change in the oxidation. Okay. Okay, so we are at our summary slide. These are the major concepts which we have covered. Let's revise. Oxidation is loss of electrons, while reduction is gain of electrons. Common oxidizing agents include oxygen, chlorine, and potassium permanganate, KMnO. Common reducing agents include hydrogen, sodium, and iron. a number assigned to an atom in a compound that represent the number of electron it has gained or lost. Chemical reaction that involve the transfer of electrons from one species to another, resulting in a change in oxidation number, and a step-by-step process to balance the number of electron lost and gain in a redox reaction, ensuring the law of conservation of mass is obeyed. So these are some, this is the summary of whatever we have studied today. Okay, thank you.